Thank you, Anna, for introducing the session. A very good day to everyone. Thank you for joining. Welcome to AI for Good's AI and Machine Learning 5G webinar. My name is Jiaying from ITU, the International Telecommunication Union. Today, we're having another exciting webinar challenge, another exciting challenge launch, which is called Generative AI Applications for Enterprise Scenarios using OPEA, which is Open Platform for Enterprise AI. This webinar serves as an introductory webinar to the relevant challenge, which aims to leverage the existing technologies and modular AI components that can be adapted and composed to solve practical problems in real-world business scenarios. In the webinar, our speakers will introduce this OPEA platform, explain the tasks to be accomplished by the participants, evaluation methods, logistics details, and also the exciting prizes for the winners. But before officially kicking off the session, I would like to introduce our esteemed speakers, Shan Wang and Lia Yuan. Dr. Wang is the Technical Director of the Software Engineering and Client Product Group at Intel China. Dr. Wang will give introduction to this OPA platform that participants will be using. And Lia Yuan is the open source and standardization engineer at ZTE with specific focus on the field of AI for telecommunication networks. Lia today will give us more details about the problem statement of the challenge and tasks to be accomplished, and the logistics detail of the challenge itself. And finally, my colleague Vishnu will be taking care of the Q&A session. Now, without further ado, I want to pass the baton to Dr. Wang. Dr. Wang, please switch on your camera and audio. Please, you're invited now to speak, to present the OPEA challenge to our speakers, to our audience. Thank you so much.
Hello, can you see my screen?
It's coming. Yes, we can see it now.
Okay. Hello, everyone, and welcome to today's webinar. So I'm going to introduce open source project. It's called OPEA, which will be used in this challenge. And the project's primarily for the enterprise AI. Yeah, I cannot go to the next one. Okay, a little bit slow, sorry. So first page is about the background. So we know there's I think since 2022 and generative AI is very popular in the world. So the first wave is from the personal consumption, but for enterprise AI, for enterprise to adopt the generative AI, there's a lot of barriers. So this page is from Gartner survey, user survey. We know there's barriers from enterprise to use the AI. I think we list. We can take one of the example. We list a lot of factors like technical implementation, cost, data availability, and also the security. But we can take one of example like security. So enterprise is afraid that their internal data or internal document to be leaked in the internet. So they are not afraid of to use the large language model as published by the internet giant or the other big companies, because so they want to. This is one of the biggest challenge they meet to adopt the AI. So they want to different from the personal usage. So they want to primary deployment, primary cloud deployment, or especially use the LLM internal inside the enterprise. So we list most of the problem here. So security is one of them. As far as I know, I meet some of the customers. They express their concerns to use that AI. So to summarize this page, we have the technical complexity. Before using the AI, probably the enterprise doesn't care the AI technology. They just want to use that. So, but the technology is changing every day, changing yearly. So technical complexity is the first factor, and cost. Probably people will think, if my enterprise adopts AI, should I buy expensive GPUs or particularly to buy infrastructure, AI infrastructure? The cost is very high, so that doesn't allow there to enter the AI area. The another one is tenant. So should they hire AI tenant to be to guide the enterprise to adopt that? That's a lot of challenges. So our purpose, our approach is to propose a solution which is using the open ecosystem to solve all the issues, all the concerns they have. So regarding the ecosystem complexity, we just list a page here. In this page, we have some boxes. So if one enterprise adopt a generative AI, they will meet the issue. So first one, prepare the data. The data is internal data, enterprise internal data. So they will use like a vector database, or they will use a storage or other ISVs. That's the first thing they will meet is that vendors they have. And second one, if they prepare the data, the second one is to build the LLM. How to use the LLM? The public LLM is for general knowledge. It's not for specific for the enterprise. So the first thing they will fine tune the data, fine-tune with the LLM with the internal data. So they will build LLM, they build their own models. And the last one is deployment. As I said, the enterprise doesn't care about the AI technology. They just want to use that. They just want to use the AI to bring values to their enterprise. So they will meet the system integrator. They will meet the OEM hardware. They will buy hardware. They will use meet the OSVs, the operating system vendors. So all of this will give the as one solution to the enterprise. The enterprise doesn't want to interact or communicate with so many vendors. They just want to one solution they can use to bring value for them. So our open OPEA, the project name is for, Open Platform for Enterprise AI. So our goal is to build the specification component and the microservices and the reference flows and the evaluation benchmark. We also have the benchmark tool inside the open source project. You can use the tool to evaluate the performance and the other AI infrastructure. Okay, that's this page shows the typical rack. If you, as I mentioned earlier, so the first thing for enterprise to build the model is fine tune, but fine tune is also need the enterprise to use that AI infrastructure, which is a little bit expensive also. So another cheaper or cost-effective solution is to use a RAG, retrieve augmented generative AI. So this is a typical flow of RAG in OPA. So OPA leverage RAG, and then OPA doesn't need the enterprise to use the fine tune. But we also allow enterprise to use fine tune. But the first priority we used is RAG. So you can see in the picture, flow enterprise data, this database, all like the enterprise document, image, video, email, and chat history, and technical database. All of these are primary, internal. It's not allowed to be public. It's not allowed to be accessed through internet. So all the data will go to the vector database that will we use that embedding or to data preparation to map that data into a vector database. So from the top, if a user requests a query, ask a question for the LLM, so the query will be translated. First thing is the query will ask the vector database and translate the query to be another query. We can call it a prompt engineering, another query which the large language model can understand. So in this process, we have the embedding. Embedding is a data preparation. In this uh, process, we have embedding on the retrieval and the re-ranking. That is a typical process in RAG. And after re-ranking, we get another query which can be inputted into a large language model. So this box, if you can see my mouse, anyway, but there's a box is called LLM inference. So that model is a general model. We can use the open source model. We can use the commercial model from the external, but we use the external model, but all of the model should be deployed inside the enterprise using primary private cloud. And after we ask the model with a new query, and we through the guardrail, maybe we can make the output safe, and we can get the response to the user. So that flow through the that flow through the vector database. That flow is we ask the question regarding the internal data, the enterprise private data, but we can ask the question. We can translate the question and ask the question to the general large language model. And on the other side is the user feedback, because sometimes the result is not good enough. So we can use other mechanisms like fine tune to change the model. This is why I say that OPEA allow the fine tune, but the fine tune is not first priority. RAG is. So that in that way, so we can satisfy the enterprise needs, can solve the security issue, solve the security concern. We can use the cloud infrastructure for scalability issue and reliability issue, and without fine tune, without training. So RAG is right now, I think right now the most low cost low cost method. So that is why we propose OPEA, that's Open Platform for Enterprise AI. So this we just use a slogan, enable enterprise to develop and deploy generative AI solution powered by an open source to deliver on security, safety, scalability, cost efficiency, and agility. All of this that the enterprise needs. So look at the stack. We can see the position of OPEA project. We know that below the OPEA, we have a lot of frameworks, the famous PyTorch, TensorFlow, and above the general framework of AI, we have the serving framework. So typically, like we can use VLM. So we can see VLM. So we also can use like SGLang and other commercial or open source serving framework. And we have the application framework like LangChain, Haystack, Llama Index. So OPA serve as a middleware between the low-level frameworks and the upper-level application. So when so you can see after above the OPA, we saw a lot of applications. That is why we need the ISV, we call the software vendors, to build on top of OPA. They don't need to consider which framework, which application framework, which serving framework they are going to use, but just call the OPEA API, the microservices can build the solution or AI application for the enterprise. So that is the position of the OPA in the AI software stack. So look at the OPA architecture. From bottom to top, we can see that we have the low-level hardwares like CPU, GPU from different vendors, and above the hardware we have the operating system Linux But we know we have a lot of Linux distributions. So that is the OPA OPA is compatible with on those Linux distribution. We can use like Real, we can use Ubuntu. In China, we can use OpenEULA. OpenEULA right now also support the OPEA. So on top of Linux operating system, we can see there's a GPU drivers. It depends on which GPU you are using in the hardware. So besides the GPU drivers, we also have like GPU libraries. If you use the NVIDIA GPU, so in this layer, CUDA should be used. If you use the AMD or Intel, we should use like ROCm and one API respectively. So that is so all the issue is solved by the OPA. And on top of the library, GPU drivers and the libraries, we can see like different deployment. So we can deploy the OPA on single machine. You can use .compose to deploy onto the single machine. We also can deploy onto cluster. We have a lot of machines. We can use the Kubernetes, or we support the other softwares. So this layer is called the orchestration layer. I think in this layer we use the cloud software to deploy on top of that. And on top of orchestration, we saw many yellow boxes. That is the key, key value OPA delivery. So all the services packed as microservices in OPA. So we can see the biggest one is inference. We use LLM for AI inference. So you can see in OPA we support different models like DeepSeek, Qianwen, and Llama, and also other the commercial. But in this open source, open ecosystem, we want to support more and more models, but we need everyone's contribution to support more models. And we below the model, we know that is a serving inference framework, serving framework. We can use VLM, we can use Olama, and now we can use SGLang. So this all of this the users or maybe you can software vendors doesn't need to dig into the details of OPA. All of the components is packed into one microservices. Microservice is called inference services. So the on the top we can see some boxes representing the AI application. If you are writing an application, AI application, you can call inference microservices to consume the large language model to do the inferencing. So that is the key value. So we also saw another some of the other yellow boxes. That is also the other microservices OPA is offering, like ASR. ASR means that you can ASR the text to audio to text or text to audio. We can use like re-ranking. Remember, in the typical RAG workflow, we have the box to represent the process like embedding, re-ranking, retrieval. So all of those process is also packed into the microservices. So we can see the re-ranking, we can see embedding. Also, we can see the guardrails. So if you want to add a guardrail into your application, you don't need to write it from scratch. You just call the guardrail microservice. That can help you to do that thing. And if you want to have an application to translate text to image, you just call text to image microservices. They can help you to do that. So that is the OPA architecture. As I just want to emphasize the most valuable component OPEA offering. is offering is the yellow boxes or yellow microservices. All you should do is just call the API. So we support like more than 20 OpenAI API compatible microservices. Mm. If you write something, if you write an application using OpenAI API, you also can replace the OPEA API with replace the OpenAI API with the OPEA API. What you need to do is just deploy OPEA inside in your enterprise and inside in your the lab for as a private cloud. Okay, that is the link of the OPA project. If you are interested in the project, you can type the link and access the source code of OPA project. The source code is on top of github.com. So in the code repo, we have several, we can say a subcode or subcode repo, or you can say that is like a directory, like a GNI examples, GNI component, GNI infra, and GNI evaluation. I just want to spend some time explaining a little bit. Like GNI evaluation, as I said, the OPA provide the evaluation tools or benchmarking tools you can use for if you build the solution for the enterprise AI, you can use that tools to measure, to evaluate the performance of your system, like latency, like concurrency, etc. And another tool is called GenAI Infra. If you remember that we use the cloud software to deploy the microservices. So all the cloud software are in the GenAI Infra repo. So if you that is for the containerization and the cloud native suite for OPA. And the component, all the microservices, the yellow box microservice are inside the GenAI component directory or code repo. And we also in OPA, we also have some of the examples or some of the samples to show how to write the code, how to write the AI application, leveraging OPA. So you can refer to the examples to write your own AI application. That example, all of those examples are calling the OPA API to fulfill the task. So that is the detailed architecture for the microservices. So we just have three layers. Like the bottom is the microservice I just presented before, and in the middle layer, uh, we know we have the microservice, but if you want to fulfill a task, to do a real thing, you just need the we call it pipeline. We need the pipeline all the microservice for just one task. Not all, but some of them. For example, we have one example in the OPA repo. It's like a chat Q&A that you can ask a question. Ask a question based on some enterprise document, and the example can answer your question, and but that is similar to the chat window, like Chat GPT, but that not that power, but it's specific for internal enterprise document. But we don't have the chat. We don't have the chat Q&A microservice, but the chat Q&A chat Q&A application is composed of I remember seven microservices. How to link all the seven microservices? We just need the pipeline. We call it pipeline. So we have different options for the pipeline. In the OPA, we have mega services. Mega service is one pipeline. We also have the GNI Studio. This is another repo. We also can use the external third-party pipeline tool like Flowise, or in China we have DeFi. We also can use that pipeline to chain to make the microservice as a chain to fulfill the AI application. So that's there is called pipeline. Pipeline is also necessary for the OPEA. And on the top, that is a different example or applications. So this page showed some of the key features. As you know, as the OPA is involving people, I mean the community contributors will add more features inside the OPA project. If you see any new technology happened this year, we try our best to add the new technology inside the OPA. Like we support MCP, we support A2A, support the AI agent. So this feature is not the full list, just a selected list. So some of the feature is for the core capability, like agent. We support AI agent. We support image to video. We support multimodal. We also support different models, large language models, but we know there's a new model are coming every year, but we try to support new models. And the RAG, now we support the knowledge graph. As I said, we support multimodal. Security, we just add more code to make sure the entire system more secure for enterprise usage. And the other thing is it's from different factor, but as I said, I just want to expand them one by one. But that is, I think, the selected the primary key feature in the OPA project. It's also changing. It's also evolving. Yeah. This page shows the OPA partners because as you know, the OPA is an open source project. We need from the architecture, we saw there's a lot of layer. We have the hardware layer, we have uh, mm, Linux system layer, we have the GPU layer, GPU driver, GPU library, we have the inference layer, we have like a model layer. So we need you can see if each layer stand for many vendors. So we need everyone's support. We have hardware vendors support in OPA. We have model layer, model vendors to support that. We have OS layer, OS vendor to support, like we support Rail, Red Hat. We support OpenEULA. So that is open system, open source system, open ecosystem. So we do the same in the open source way. We need everyone's contribution to make the projects better and better. Another thing is we also under the Linux Foundation's guidance, I can explain a little bit. We create a alliance. It's called Open Intelligent Computing Industry Alliance. So in this challenge, OPA challenge, this is we rely the alliance to host the challenge for the entire event. So the alliance is supported by many companies. You see that we are supported by Intel, supported by H3C, ByteDance, and the China Mobile, Alibaba, etc. So that alliance is, I think, is trust advisor to support that OPA project. Right now, OPA project is incubated under Linux Foundation, but source code is on GitHub. So that's it. That is a part. Some of the members in the alliance, in the COIA for short. That's a part of the members. So we just want to show two examples, the two adoption examples, leveraging OPA. One is called Infosys. So there's Infosys use RAG and OPA to implement their employee assistant. So the employee, Infosys employee can ask, can use the AI, use the inference with the OPA to answer many questions based on the internal document, internal content, pre-sale activity, and the policy search. So all of the information, all of the system is inside. It's deployed inside the Infosys. It's not accessed by the public. It's not accessed by the internet. So that is one of the example to leverage OPA and the RAG to implement the enterprise generative AI. Another example is NetApp. NetApp also use the OPA. It's a use and this is a use of OPA software, and the other one is the hardware. It's use Intel Xeon server and also the NetApp A20 storage server to build a this called a one all-in-one the hardware, all-in-one devices that can sell to the other enterprise to use the software and the hardware easily. Not not every enterprise is technical. It's not that technical. So that you can use the all-in-one devices or all-in-one hardware easily to for the internal inference, AI inference. So we also have an online demo that can show the capability of OPA. If you are interested, you can access the YouTube link to watch the online demo. I think we also have some of the link or the QR code for you to scan if you are interested in the project you want to contribute, or you want to if you have any question or meet any question when using the project, you can ask the contributors ask the community in the website, and you can get a response. So I think that's all. Our challenge is based on OPA, so you can use OPA to build your works, build your applications to join the challenge. If you don't know how to do that, remember we have a repo. It's called the GNI example. You can refer that code, refer that GNI example code to write your own application. I think that's all for today. Thank you for watching.
Thank you, Dr. Wang, for your very precise and detailed introduction. I guess our participants would like to know more about the challenge. I would request Leah to kindly share more details about the challenge. And meanwhile, for Dr. Wang, if you could please share the QR code and also the link with me so that I can share with our participants who is watching online. Thank you.
Okay, no problem.
Hi everyone, can you hear my voice?
Yes, we can hear you and see the screen.
Yes, great. Thank you so much. Hi everyone. I hope everyone has gotten clear idea of what OPEA is, because that's the most important project if you want to take part in our innovative challenge on generative AI applications for enterprise scenarios. This is a challenge organized by COIA, which is mentioned by Dr. Shen. It's an alliance for open intelligence, open AI, open artificial intelligence and its underlying infrastructure. And ZT and Intel are two important members in this alliance. And we also thank FGAINN for its support to this challenge. This challenge, all of the important details are already on the website. Today I'm going to go briefly of this challenge and show you the background of it and what information you need to know about it, and what's the task of it, and what you need to what kind of things you need to do to complete this computation. And first, before we dive into dive into the details of the challenge, let's look at the latest trend of this AI revolution. We've witnessed that the enterprises are facing increasing pressure to integrate advanced AI capabilities. For example, the LLMs into core business systems securely, efficiently, and cost effectively. And For example, let's take telecommunication networks as an example. As a key infrastructure for digital transformation, the networks are undergoing a paradigm shift towards AI native architectures requiring deep integration of AI throughout the network. And this kind of AI native architecture paradigm shift is not only in the telecommunication networks, it also affects other critical sectors, for example, the intelligent transportation, also the smart energy grids and other critical areas. And facing the trend to integrate the AI, the LLM into the enterprises, we still face a lot of enterprises challenges. For example, the fragmented technology stack, and also we need to balance the performance and the total cost of ownership. And there is also many complexities brought by the cloud-native deployment and the Kubernetes orchestration, also the large-scale AI model evaluation. And also, even if you have the prototype for your experimental models, you still have some engineering tasks and challenges to deal with to really get your models into the enterprise scale deployment. And that's why we are, and the solution for this kind of challenges is OPEA, because it provides a standard modular framework to address these challenges. About what is OPEA, Dr. Shan has showed pretty much about it, and I won't dive into the details of it. But we can briefly think of OPEA as a Lego set for AI, because it provides the modular and the modular building blocks for you to build your own AI pipelines, because you have the core components such as the LLMs, the RAG pipelines, vector databases, prompt engines, orchestration tools, and also the tools for you to evaluate your Gen AI applications and solutions. So here is your mission today, and also for the coming few months for you to complete your challenge is to design, prototype, and demonstrate a domain-specific generative AI applications using OPEA. The 4 things that you need to keep in mind is, first is to use the OPEA's modular components, such as the LLMs and RAGs, to construct a solution tailored for your enterprise needs. And you can also start from an existing OPEA blueprint or build a new pipeline, use these reusable components. And the second thing you need to pay attention is that the vertical domain that you choose should be with the practical value. Your applications should address real enterprise pain points and demonstrate measurable business impacts. And after this building is done, you can deliver a prototype with the with your source code and also the comprehensive documentation. And the last but not least is to demonstrate your performance and usability. You need to ensure that the prototype is optimized to run on typical enterprises hardwares with clear performance metrics and also excellent user experience. And here are some examples of the targeted industry verticals. Since we are in the ITU context, the telecommunication networks will be most typical scenario for you to get your solutions done. You can use OPEA to build AI native network optimization, predictive maintenance, intelligent traffic management, and also automated customer support. All of things can be done with OPEA and you can use your imagination to create more innovative solutions. And also there are some more examples here. For example, the education, finance, legal services, healthcare, manufacturing, customer support, and public service. And that's not all. You can always explore other areas or industries to create your own AI solutions, as long as it's with business value and with great performance. And when the submission is done, we will have the evaluation. The most thing that we care about your solution is the creativity and business value. We will put 30 points for it, and also we will pay attention to the technical implementation with 40 points added to it. And based on this two kind of evaluation, we will pay more attention to this prototype quality with 30 points. And apart from this 100 points, we also have some bonus points. For example, whether it's open source, whether it gets some knowledge sharing part, and if it has some hardware optimization. So basically, you can get a maximum of 140 points if your solutions are great enough. For the submission, the following things are required. First is the full source code. You need to submit complete functioning code base with one-click deployment capability. Also, the README is required to provide comprehensive documentation, including the system overview, setup instructions, hardware or software requirements, and expected outcomes. Also, we need you to provide a technical report to explain your system architecture, component usage, deployment strategy, and also use case relevance. And we hope that your project is open source with an Apache 2.0 or MIT license. And it's better that if you can prepare a demo video so that we can get an idea of what your solution is very quickly. Also, you need to pay attention that we have hardware constraints. Since we are in the enterprise scenario, we need the RAM to be under 64 GB, and also the CPU should be limited within 4 cores, and the GPU is optional, and you need to pay attention that the deployment should be only a single node, and the installation should be easy enough to be contained in 10 minutes on clean environment. And here is another thing that you need to pay attention is the timeline. And today is our opening webinar. And actually, we have started our registration from February 14th. And after that, after the registration, we will have the competition phase until June 5th. And in this month, in April, we will also have a mentoring session. If you have some more questions about how to implement your solutions with OPEA, and from June 5th to June 19th, we will have the evaluation, and based on that, we will announce the winners during the AI for Good Summit in Geneva. This is the timeline that is planned so far, but we see a high possibility that the timeline will be extended. For example, to August, so that you can have enough time to prepare your coding, to prepare your submissions. And we think that will be better for you to have high performance outcomes. We will keep you noted if we have any changes to the dates. And this slide, I think, is most important for you guys because it illustrates what you can get from this kind of participation in this challenge. We have 6 winners, and for first prize, we will offer 5,000 francs, and also we can provide the flight and hotel coverage for the FGAIN meeting in China. And for the second prize, we will provide the 2 winners with 3,000 francs, and also for the third prize, we will provide the 3 winners with 1,500 francs. And ideally, the solutions will be showcased at the AI for Good Global Summit in Geneva, but considering the time constraints, it may be the timeline may be extended, so it's high possible that it will be presented at the FGAIN September meeting in Beijing, China, and it also will be supported by COIA. And there were some additional benefits for you. For example, if you get participated in the challenge, you can get a certificate of participation, and if you win it, you can get certifications issued by ITU for global recognition. And you also have some publication opportunities. And during the whole session, during the whole process of your competition, you can get connection with international experts, ministers, senior ITU experts, and the global telecom industry leaders. And I hope that's attractive to you. And here are some resources that we can provide it to you. All of them are public resources, and you can find the links via the website, and I will not dive into every part of it, but if you have any questions of it, we can discuss later. We are here today to wish that you can be part of the enterprise AI revolution. We hope that you can help to design, build, and deploy innovative Gen AI applications using OPEA's modular framework. And welcome all to compete for prizes, gain global recognition, and connect with the industry. And everyone is eligible to get part in this challenge. And if you have any questions or if you need some advice, you can always contact COIA or Shan from Intel. And thank you. That's all for the introduction of the challenge. Let me know if you have any questions. Thank you.
Thank you very much, Leah. And thank you, Shane, for that excellent presentation. Actually, the participants can ask questions in neural network. While we wait for the questions, we can have some discussion on normally frequently asked questions. So we have been doing competitions for quite some time, and normally they participant ask some specific type of questions. We can discuss some of those. One question is in the type of the theme of the competition. Why unique? What is unique about enterprise scenarios? Maybe if you could tell us what is the difference between enterprise scenarios and other type of deployments or scenarios. Maybe Shane or Leah, if you could tell us, that will help the participant understand the topic, the theme of the competition better, please.
Okay, okay. Let me answer the question. So, as far as I know, the enterprise scenario, I think the unique characteristic of the enterprise scenario are like deterministic. You don't means that the enterprise doesn't allow the AI to make any mistake, and the answer, or if the enterprise using AI to do inference, the answer should be the same without with the same queries. And the other thing, the other characteristic is like security, privacy, and cost effective, and many other factors. But I think the most important is deterministic. Uh, yeah, should everything. We don't need we don't allow AI to make any mistake when do inference for enterprise.
Vishnu, you're
It's
muted.
Sorry, sorry. Actually, maybe that's the reason why you have RAG solutions rather than fine-tuned solutions, right? Maybe the RAG allows you to be more query-based, more knowledge-based rather than and more deterministic, capturing the knowledge from the enterprise. Maybe that's the reason why you're going for RAG-based solutions.
Yes, and also RAG is more cheaper. It's much cheaper than fine tune.
Mm, 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 mm.
You don't need to buy more infrastructure or GPUs for the fine tune. Fine
Mhm,
tune is also need a training. Yeah.
mhm. In terms of how to develop these solutions, I think the steps for the participants, I think this is important for the participant to understand what are the steps in this submission, especially starting from beginning. If I'm not familiar with the OPA, how do I approach the solution development? First of all, maybe I want to understand the type of capabilities, what are the blueprints currently available, maybe, and the workflow which is being addressed. I mean, you mentioned several examples of verticals, and what is the type of solution? Is it query and answer like Infosys, maybe a query and answer solution, or maybe workflow automation? I think Leah mentioned AI native troubleshooting, so that may be a workflow automation. I don't know. So what are the important steps in the solution development if I am starting from scratch?
Okay, I also can help to answer that question. I think the most easy way is to download the OPA project from the GitHub and deploy onto your personal computer or personal cluster. And then try those simple examples
Mhm,
provided by OPA, and then brainstorm which scenario can use AI to solve the problem, and then change the example. Choose choose the most
mhm.
similar example from the OPA and change the code to satisfy your requirements or satisfy your scenario. I think this is the most I think the most convenient and the easiest way for you to start from scratch.
What is the type of solution I mean, maturity of the solution expected? Are you looking for demo? Are you looking for prototype? Are you looking for product? Uh, because if I'm a student, I am making this kind of changes. It may not work sometimes. It may not
Mm,
be always working. It may fail sometimes. What is the
mm.
maturity expected, please?
Ideally we want the solution, mature solution. But if I think it depends on how many participants, how many candidates we have. If
Mhm,
no, if no solution is mature, we will look at uh, the creative, innovative idea. Uh, if if you look at the OPA example, I think the most mature example is chat Q&A. It's a query and answer, but that chatbot is not creative. We saw a lot of chatbot, but you can brainstorm and find out one scenario that can used by the enterprise and solve the problem, solve the scenario problem, and then we will look at which one is the most creative regarding if given we don't have mature solution, but ideally we want a mature and creative solution for enterprise. Yeah.
Thank you very much. Maybe one last question is for Leah. What is the method of submission? Should I submit GitHub, maybe a repository, or a zip file, or a folder, or a Docker? What should I submit, and how and where should I submit, please, Leah?
Yeah, that's quite important questions. We can update the website to show where the submission should go. But here I can answer this question is that we can provide a GitHub organization, and you can put your GitHub repos there, and we can make it accessible to us, and we will download it for evaluation. And for the contents of the for the contents of the submission, could you please check this slide? We need to provide the code and also some explanations about your solutions. For example, you need to provide a README and also a technical report. All of them should be contained in your submission when you submit to the GitHub page that we provide.
Thank you very much. Yeah. Thank you, colleagues, for answering all the questions. It's a nice challenge, great prizes. Thank you for the planning. Back to you,
Rem, Rem,
yeah.
May I add a comments to the second question?
Yes, please. Yes, please.
Yeah. We have the criteria in the challenge. We publish the challenge. We have the criteria to grade the solution people submitted. So we will use the criteria. We'll use measured from different experts to score the submissions. And the other thing I just want to emphasize is no matter what you submitted, runnable is the bottom line. Your application should be runnable, should workable.
Okay.
Yeah.
Great. Yeah.
Thank you.
Thank you very much.
Thank you.
Thank you. Back to you, Chang.
Thank you, Vishnu, and all the colleagues for the Q&A session, and everyone who's contributing, who's attending to this talk until the end. The challenge is now available on the website, and also we have posted the challenge link on the video wall. Please, you can join now if you are interested in this challenge. Please start working on the solution and also submit your results on the portal according to the criteria mentioned by our speakers. The CPU and GPU will be provided based on needs. Just contact us and tell us about your request. We have more sessions in the future. Please check the AI for Good program page for more details. Looking forward to seeing you guys in the future. Thank you for joining. See you next time.